Alright guys, we're doing number 8 now. This one, like I said, I was going to teach you how to do this without going through the step of finding the z-value. So if you do want to find the z-value, then that's totally fine. That's a legitimate way of doing it, and you can do that where it's going to work every single time. If you do it my way, it's going to be shorter, but it requires slightly more thinking because we're going to have to change it. We're going to have to just pay attention to our bounds a little bit more carefully. I'll show you what I mean here. Let's do it the way I would do this. You know, we like to be lazy, right? As mathematicians, we try to be as lazy as we can. Mu is not equal to 8550, that's the claim. Alpha is 0.02. Sigma is equal to 314. X bar is equal to 8420. And n is equal to 38. All right, so first thing I do want to do, and this is going to be the same all the time, whether you're using the scale z or not, the scale test statistic, the z-value or not, you want to find the h0 and the h-out alternative. All right, so the claim was that it's not equal to something. That makes it the alternative because it does not include the equal, 8550. And that makes the original mu is equal to 8550. So the claim was the second one, right? This is the claim here. That looks like Dane. That should be claim. And since it's not equal, that means when we're talking about the test, it should be a two-tailed test. So I want the area on both sides. Yeah. To the left and to the right. Okay, up until now, because we've been scaling it, we've been treating the mean as being 0 and the standard deviation as being 1, right? But I can basically do the same calculation and just think of my mean here as being the true mean, 8550, and just my standard deviation as being what it is, 3 over 14 divided by the square root of 38. Yeah. So if I do that, I can do the same type of calculation I've been doing, except I skip the step of doing the z, and I just plug it straight into my p-value. So how are we going to do that? Let me show you. Since I'm doing a two-tailed test, I should do 2 times whatever side I choose. And I'm going to choose the left side because this value, x bar, is to the left of my mean, right? It's to the left over here. This represents right here 8420. That's to the left of the mean 8550, right? So I want the values from here on to the left. What's the probability that I'm over there? We're coming back to the probability sections long time ago. And we're just the same kind of calculation though. 2 times norm CDF. This is the p-value is equal to this. It's equal to 2 times norm CDF of the lower bound. Okay, lower bound though, it's going to go all the way to negative infinity, right? So normally we'd use negative 10,000. Okay, but here's where you have to be extra careful if you're not using the z-value. If you notice our values, they're pretty large, 8,000, right? And the original standard deviation is also pretty large. So just to be extra safe, since I have large numbers, large standard deviation to start with, I should choose something bigger than 10,000. I'm just going to add an extra 0. Go to 100,000. If you want to be even safer, you can go to million, but it's not necessary. So negative 10,000 up to my value, 8420. Right? After that is the mean. The mean was 8550. After that is the standard deviation, which is 314 divided by the square root of 38. So we're just going to plug that whole thing into our calculator. I'll punch it in and I'll show you that I pretty much plug exactly what I wrote down there. 2 times norm CF, negative 100,000, comma. Is there 100,000? Yeah. 8420, comma 8550, comma 314 divided by the square root of 38. So here's what I typed in. Well, the second half of it. The left half is just 2 times norm CDF. Really kind of focus in there. All right, and I'm just going to press enter and see what I get. And I get 0.0107. Now, the only thing that's important here is that that value is less than 0.02, my allowable error. So what is it saying? It's saying with only probability of about 1%, about, yeah, 1.1% roughly. Only with that very small probability is my original claim true, assuming that I got this sample, right? So we took a sample of things. I took 38. I found the mean to be this small value. But if my true mean was as high as 8,550, then this is a very unlikely thing to get. It's less than 1%, or about 1% chance that I get that, or get a value that's this far away from the mean. So what it means is I reject H naught then. Can't be true. So otherwise this wouldn't have happened. So I reject H naught, which means I basically accept its alternative. Not basically, I do accept this alternative. I accept HA. And what was the claim? The claim was HA, so I accept the claim. I accept the claim that the average is not equal to 8,550. That's not likely to have happened. Okay, that's number 8. Number 9 is going to be the same thing. 10, 11, also the same thing with just some extra interpretation. Okay, I hope this video didn't get interrupted again. I just got a message. Computer's kind of old because I'm using my older computer, because my other one is a school computer, which doesn't allow me to upload things to YouTube for some reason. They just put some kind of restrictions on it. Okay, anyways, the claim, this is number 9, that looks like a 7, it's number 9, is that mu is less than or equal to 22,500. Alpha is 0.01, sigma is 1200, x bar is 23,500, and n is equal to 45. Before we do anything, let's just kind of guess what we think is going to happen. Let's see, the claim is this, that the average is less than that value, but then I got this average that's above the value, so it seems like maybe we're going to end up rejecting the claim. But it kind of depends how far away this one is, right? How far? To me, though, it looks like pretty far because this is 1,000 higher. So it seems pretty unlikely that this is a true claim. It seems like we're going to reject the claim. But let's make sure. What is H naught? What is H alternative? H naught, remember, is the one that includes the equality. So this is going to be mu less than or equal to 22,500. Alternative is going to be mu is strictly greater than 23,000. Oops, wrong value, 22,500. Yeah. Let's just mark the claim. This was the claim here. As far as the tail test, we look at the alternative, which is the greater one. So we're looking at a picture like this to the right. Okay, I'm going to skip the z step just like the last time. I'm going to go straight to the p-value. I'm doing a right tail test, so it should be norm CDF. My value, which was this 23,500. I'm writing it without commas because if you type a comma into your calculator, it's going to get confused and think this is the first term, this is the next term, right? So 23,500 without commas. Next value is the upper bound. So like 10,000 normally we would use, right? But again, our values are large, yeah? Values are large. Standard deviation also very large. So I should use a larger number than 10,000. Let's just do 100,000. You can even do 1,000,000 if you want to be safe. Okay, after that is my mean, which we know to be 22,500. Again, with no commas. And finally, the standard deviation, which is 1,200, but divided by the square root of n. So that is the whole thing that you're punching in. All right, let me punch that in and see what we get. Norm CDF. 2,3,500. 1,000,000. Or whatever, you know, actually 100,000 should have been enough. 22,500. 1,200 divided by square root of 45. So it looks something like this. The front gets cut off, but You get the picture. Press enter, and I get 1.13 times 10 to the negative 8, which means this is going to move over 8 times, giving me 7 zeros in front. That's way below 0.01. Yeah, this is a really small probability. So if I assume that H naught is true, then it's very unlikely, this is really small probability, it's very unlikely that I would have gotten this X bar. It's very unlikely that my sample mean would be that large. So what that means is that I'm going to reject H naught. Reject H naught, which means I accept the alternative, but I don't have to go that far because the claim was H naught. So I reject H naught, which means I reject the claim as well. There it is. There it is. It's all starting to come together, right? As you see these questions in action, see what they really mean. Okay, we're going to stop now, and then I'm going to go on to the last